make it affordable. Now, if you see, if the space sector has to sustain, somebody has to think about this, because you see, we had the first space tourist going something like 20 years back, but one would say that the sector hasn't taken off really. There haven't been so many people. And the prime reason for that is affordability. Unless you make it affordable, it will not sort of be there for the common man. The second factor, one would say, is the fitness level, but then affordability is important. So I think they've done wonderful work as far as that goes. And even today, the kind of frequency that they launch, SpaceX launches, it's unimaginable. So many rockets going every month. Now, the failure that they happened was in a developmental rocket. It's a larger size rocket. It's not the standard Falcon 9 rocket. It's a larger rocket which they are developing for future. And therein, when you're doing these developmental activities, and they had declared this launch as well as the previous one, which was also developmental rocket, there are bound to be these kind, because they're trying many things for the first time. Even the reproducibility part, which they tried for the Falcon 9 first stage, initially it had some issues, but later on they were able to perfect it. And this is a company which goes hand in hand. For them, since they have that autonomous and decision making, they are able to take calls. So they are able to even declare these kind of failures that they have as stepping stones or as learning curves. So I think they're doing it beautifully. So I don't want really to say that there's something wrong with the way they are approaching things. They have their own way of thinking. It's different from the agency's perspective. Many space agencies in the past, including NASA, ESA, ISRO, we've worked in a particular way, we've handled the launch vehicles in a particular way, but SpaceX has a different way of thinking. And you've got to support them for their innovation, even if they have one or two setbacks. Thank you.
Yes, so we get a mic across. No,
Yes, mic.
first over. You got a mic. Oh, you just go across over there. Ma'am, over here to the gentleman. And then I'll come to you after.
So I'm Sarvagya Dwivedi from Silicon Valley. The question on supply chain, ISRO's supply chain. For all these complex missions, how much of your supply chain is totally indigenous, Bharat-based?
See, if you see the Chandrayaan 3 itself, if I take, there are various electronics and mechanical systems are there, which is all made indigenously, and many vendors played a major role in realizing the systems. So if you see mechanical systems, we have propellant tanks, we have engines, we have mechanical housings. All these things are made by the vendors. When it comes to electronic systems, the printed circuit boards and again the wiring, everything is done by indigenously. But components, certain components, electronic components, which is procured outside, a kind of FPGAs, ASICs, those are all bought out items. But that also largely we have made indigenous. In fact, the overall Chandrayaan 3, if you see, the propulsion module, lander, rover, rocket, everything is made indigenously. We only took a support of external ground station, which they also take a support. Like when they launch, we require continuous 24/7 telemetry and telecommand support is needed, because when the spacecraft is going towards moon, we require that kind of a support. Globally, the stations has to be separated for us to constantly communicate. So we took a support from JPL, 3 stations, one is Canberra, Madrid and Roadstone. Similar way from European Space Agency, we took 2 ground station support, one is Kunali and Kourou. So this is the support we have to obtain. The same way it is applicable for them also.
Yes.
Hi, my name is Kumar Bagrodia. I'm an applied neuroscientist. We use deep brain-computer interface technology to help people understand their brain waves and help you change them. My question is in the context that if ISRO is really planning to put a man or a woman in space, I'm sure you would also be looking at the impact that space travel has on neuropsychological issues and the neuroanatomy. So are you all using any technologies to understand that and prevent psychiatric issues there?
Okay. Thank you for the question. Good that you asked this question, because when we talk about a human spaceflight program, I think space health and space medicine becomes of utmost importance. And I think that also relates to the theme of this event. We're talking about Global Bio India 2023, and Department of Biotechnology is organizing this. So I think the for human spaceflight program to be sustainable program, the drive has to come from human being. And human being itself, even though we plan to fly some payloads, experimental payloads and all, but the most important payload will be the astronaut himself, the human being itself. And from the large amount of experience that we have got now, see, we are not the first ones to go into space. So we know that microgravity, the space environment, it sort of affects every part of the human body. It affects your muscles, it affects your bones, the blood moves up, you have cardiovascular system upsets, you have kidney stone formations, it affects your psychology. The long duration missions, of course, you are in isolation. So all that has its impact. But the good thing is that whatever data we have, it also shows that whatever impact microgravity or space environment has on human health, it is not irreversible. What we have seen is that astronauts have come back after 6 months, 1 year in space, and after a particular period of rehabilitation ranging from, let's say, a few weeks to 3 months or 4 months, they're able to get back to the previous health. Also, the data has not shown that in any way the lifespan of an astronaut or a human being who flies to space gets reduced. So those are good aspects. Now, very specific to the psychology aspect, so definitely for long duration missions, we will need to carry such devices. For the present, what we are doing is we are trying to do a study on cognitive load analysis for the human beings in the cockpit environment. And this study we have taken up with the Indian Institute of Science, where by means of using eye trackers and EEG data, we are trying to evaluate in the crew module for the kind of tasks that are given to the astronaut to execute, what sort of relative increase or decrease in the cognitive load that happens, and how that data can be used to improve upon the cockpit environment. So this is where we are today, this is where what we are practicing, but this has implications for future. So in future, there will have to be more this sort of analysis. And mind you, the psychological aspects are one of the most important criteria that you use for selecting an astronaut, especially if it is a group. So you need to have a lot of those criteria taken into consideration. Thank you.
One or two more questions. To this young boy over here, yes.
Yeah, my name is Sahil. I'm a student at Shinada School in the 11th grade. So during the 50s and 60s, there was an intense space race, and countries were pouring money into the space programs. And the public also agreed because it was a matter of national pride. But after the space race ended, some people started to oppose this idea of pouring so much money into space programs because they thought that money would be better put to use in programs with improve poverty and homelessness and wars. And what would be, open-ended question to all of you, what would be your sort of rebuttal to these people that why should money, public funds, taxpayer money be spent on space programs and space research?
We were talking about this before we started.
See,
He asked the right questions. Right? Go ahead.
see, this was being questioned for a long time. If you see, the space has got a relevance to the common man. Our programs are not only going to the moon or Mars. If you see the ISRO program, it is for the societal problem. There are various applications, around 250 applications we are taking out of the space, like remote sensing. We have different types of remote sensing satellites for crop estimation, natural resource monitoring, then climatic research, atmospheric research. Similar way, we have a communication satellites. We have a series of communication satellites for, again, different applications like DTH, telemedicine, teleeducation, broadband services. There are various applications. Similar way, navigation satellites. We have our own IRNSS, which gives the navigation things like marine. Then there are various applications are there. Again, we have space science. Space science also. See, sometimes back when Arthur Clarke has told, you put a satellite at 36,000 kilometers, three such satellites at 120-degree apart, you can cover the entire globe. People laughed at him at that point of time. Now, if you see that the entire 36,000 kilometer orbit is fully crowded, how the real estate is so demanding, similar way there it is a big demand. So because the satellites is giving for a common man, there are various applications. We are generating a lot of, in fact, if you see the space economy, our contribution is very less from the Indian space program point of view. So that's why the private players are coming and we are encouraging the startups and all. So there are various applications. Now, if you are thinking about going to moon, so we have to see that in future we can have a human colonization. We can also use some resource utilization.